Hi there. So this time we're going to be doing differentiation rules, and we're going to be doing four specifically, four of the most important ones that you're going to need to know when differentiating. The first being the power rule, followed by the product rule, and the quotient rule, and finally we're going to do the chain rule. So let's start with the power rule, and we'll start with the general form of the power rule. So here you can see if you were asked to derive something such as x to the n, as written there, its differentiation would simply be n multiplied by x to the n minus 1. So you bring down that exponent and then subtract 1 from the actual exponent. So I have a few examples lined up here that I'll show you. So the first one is if you were asked to find, like if you were asked to differentiate x cubed, you'd bring that 3 down and then go 3 subtract 1, which is 2. So it would be 3x squared. The second example is a full polynomial, like a 3-term polynomial, 2x squared plus 3x plus 4. Now if you asked to differentiate that, you would bring that 2 down from the exponent and multiply by a 2 to provide a 4. And then 2 minus 1 is 1, so you can just write 4x. Now for the next part, it's 3x raised to the 1. The 1 isn't shown, but it's there, so if you were to bring that down, it would just be 3x, but it's to the 1 minus 1, which is 0, so the x goes away, so then it's just 3. And 4 just is a constant term, so that ends up going to 0. You could write plus 0 at the end, but it's not needed. In example 3 here, you can see if you were asked to differentiate root x, you can rewrite it as x to the 1/2. So bring that exponent down so you have 1/2, and then x raised to the 1/2 minus 1 is negative 1/2. So then you can rewrite that as 1 over 2 times x to the 1/2, because a negative exponent can be brought down to the denominator. And then you rewrite that as 1/2 or 1 over 2 root x. Next we're going to look at the product rule, and first again we're going to start with the general form. And it's basically saying if you're asked to differentiate something that's multiplied by something else. So here you can see f of x times g of x. That equals f of x times the derivative of g of x plus g of x times the derivative of f of x. And you can remember this by doing first times derivative of the second plus second times derivative of the first. So let's look at an example here. If you're asked to differentiate something like x squared times 3x, you would simply have the first, x squared, times derivative of the second, plus the second, 3x, times derivative of the first, which is x squared. And that can be rewritten as x squared times 3 plus 3x times 2x, because the derivative of 3x is simply 3, and the derivative of x squared is 2x, because you bring down the exponent and subtract 1 from the exponent, so it's 2 to the x, no, 2 times x to the 2 minus 1, which is 1. Then you simply multiply those together and add them, so you get 9x squared as your derivative. Example 2 is if you're asked to find the derivative of something like x cubed plus 3x plus 4, and that being multiplied by 3. Now you could simply multiply this in and then just do the power rule on it, but I'm just showing you as a visual way to see the product rule itself. So again, first it's first times derivative of the second plus second times derivative of the first. And simply we know that derivative of 3 is 0, so the left-hand side of the equation ends up going away because you're multiplying it by a 0. And the derivative of x cubed plus 3x plus 4 is simply 3x squared plus 3, because you drop down the exponent and you use the power rule and subtract 1 from the exponent. Then you simply multiply that 3 in, and you know the derivative of this function is 9x squared plus 9. So next up is the quotient rule, and here's the general form for it. So if you were asked to differentiate something that was f of x divided by g of x as a general function, you would say it's g of x times the derivative of f of x minus f of x times derivative of g of x divided by g of x squared. Now a simple way to remember this is there's a little rhyming scheme that goes if you assume g of x is low, what we'll call low, and f of x is what we'll call high, then you say low d high minus high d low, and you say square the bottom, and away we go. So basically, it's low d high, where d means the derivative of the high one. So it's low times derivative of high minus high times derivative of low, and you just square the bottom. So it's low d high minus high d low, square the bottom, and away you go. So a quick example of this is if you were to have something like x squared plus 2 over 3x plus 1. Now, you would do low, which is 3x plus 1, times the derivative of high, which is x squared plus 2. And then you go minus high, x squared plus 2, times the derivative of low, which is 3x plus 1. And you just square the bottom, 3x plus 1 all squared. So the derivative of x squared plus 2 is simply 2x due to the power rule. And the derivative of 3x plus 1 is 3, again, due to the power rule. Then you see you have that function there, and if you multiply this stuff in, again, there's the same function, but if you multiply it in, you can see that you have some like terms. You can subtract off 3x or 6x squared minus 3x squared, and you end up with the function 3x squared plus 2x minus 6 over 3x plus 1 all squared. So you can expand out that bottom term, but there's not really much point. It might make it look a little nicer with the quadratic over quadratic, but it's fine leaving it just like that. So one quick rule with the quotient rule is that you don't actually have to do the quotient rule. You can use the product rule very simply if you bring up the denominator as something raised to the -1, and then just do the product rule that way. But moving on, we have the chain rule, and we're going to start with, again, the general form of the chain rule. So it's if you have a function inside a function. So if g of x were to be a function inside of f of x, you'd basically do the derivative of the outside, leaving the inside in. So the derivative of f of x, leaving g of x exactly how it is, and then you multiply it by the derivative of the inside. So it's called the chain rule because you have some function, and then you have to chain on the inside of the function, its derivative. So we'll show an example of that. So say if you have x squared plus 3 all raised to the 5. So you do the derivative of just the outside, with leaving the inside intact, and then you do the derivative of the inside. Now moving on to the next step is, so you bring down the 5 as a power rule. The 5 comes in the front, and you drop the exponent down from 5 to 4. And then you multiply it by the derivative of the inside, where that is simply just 2x, because the x squared, the 2 comes down, and then you subtract 1 from the 2. And therefore, you just multiply the 2x by the 5, and you have a 10x multiplied by x squared plus 3, all raised to the 4. So that's simply the chain rule. Do the derivative of the function, leaving the inside perfectly intact, and then multiply by the derivative of the inside. And this gets tricky when you're dealing with trig functions and things like that, where you have other functions inside, say a sine or a cos. You have to remember to do this always. But that's the general form and a single example. Next up, I'm just going to go over the rule overview for you. So here we have the power rule overview, product rule overview, quotient rule overview, and the chain rule overview. Those are simply all the general forms of each, and they're very helpful to memorize, and if you need little mnemonic things to help you memorize them, it helps a lot. Product rule, first times derivative of the second plus second times derivative of the first. Quotient rule, low d high minus high d low, square the bottom, and away you go. And chain rule, remember you always just, if there's a function inside of another, you have to do the derivative of the inside function also, and that's simply multiplied on. And again, the power rule is fairly simple. Just drop the exponent down, and then drop the exponent itself down by a single value of 1. And that's all for this tutorial. I hope it helped, and if you have any questions, feel free to message me, and thanks for watching.